This is a quick video on section 11.5 uh, related to lines and their formulas. A line requires necessary data to construct the equation of it. The first thing you're going to need is you're going to need a point on this line. Okay, maybe we'll call it, for example, a point P. The second thing you're going to need is a direction vector. Okay, typically we call this V. Okay, so just as a quick sketch of what we're trying to construct, we're trying to construct the equation of something that goes through the point P and points in a certain direction V, and then we would like to come up with the equation of this line. The pink thing is what we are trying to construct the equation of. Okay, it's going to be the equation of the line is going to be a special case of a vector valued function r of t. So what we're looking to do is to create an x of t, a y of t, and a z of t. And we'll see that x, y, and z have a special form. Okay? So why don't we just start with a straightforward example here, just to get us going. Okay? Let's say I want you to find the line, the equation of the line that goes through the points P, and maybe the point P is 1, 2, and the point Q is equal to 3, 4. Okay, so what we're going to need, first thing you're going to need a point P, so why don't we just choose one of the points P that's already labeled P. We'll just choose that to be 1, 2. For the direction vector, V, we need the vector that points from P to Q, which is constructed by doing the difference of the 2 points. So Q is 3, 4, and the point P is 1, 2, so the difference of these two is 2, 2. So there's your direction vector. So the equation of the line is of the form point P plus the direction vector times t. This is how you construct the line. Okay. Notice that V is kind of playing the role of the slope of the line, but it's a slope in multiple dimensions. And P is just a point that the line goes through. So if the point P is 1, 2, and our direction vector is PQ, okay, let's use PQ to be 2, 2, which we just found, and therefore here is one form of the equation of the line. This is maybe called the vector form. Okay. If you would like to do a little bit of vector operations in algebra here, we can do the scalar multiplication of t to the vector 2, 2 to give 2t, 2t. And now I can do vector operations to add these two vectors to give 1 plus 2t, 2 plus 2t. So here we are seeing our parametric form, or our parametric form. Okay, so this is telling us that x of t is equal to 1 plus 2t and y of t is equal to 2 plus 2t. Okay, so it is the equation of the line is a special case of an x of t, y of t, but it's of the form a constant plus a constant times t, and then a plus bt, a constant plus a constant times t. So this is what makes a line special, is that the functions x of t and y of t are of this special form, constant plus constant times t in each entry. Okay? Just to get a little bit more of a feel for this problem, let me ask the follow-up question. Can you find 3 points on this line? Okay, L of t. So there's a couple ways to do that. Okay, here's our line in parametric form, but we also realized that it was in vector form 1 plus 1 comma 2, 2 times t. So there's our point plus our vector times t form. So this is of the form p plus v times t, where v is the vector p to q. Okay, so 3 points on this line could occur, right, when t is equal to 0. At the time t is equal to 0, we are at the point 1 plus 2 times 0, 2 plus 2 times 0, which is also called 1 comma 2, which was our starting point p. Okay. Another way to see that is to see where the p comes from is to look actually over here at the vector form. L of 0 is the point p plus our direction vector times 0, but 0 times the vector v is just 0, so there we go. This is why we know we're at the point p. Okay. At t is equal to 1, we're at a time of 1, which means that t is equal to 1, so 2 times 1, 2 plus 2 times 1, which is also known as 3 comma 4. That happened to be the point q. Well, why did it work out like that? Well, you could either plug in the values of t and then do the arithmetic on each entry, or you can say that at time 1 we're at the point p plus direction vector times 1, but our direction vector was p to q times 1. But our direction vector was a difference of 2 points, and therefore p plus q minus p. P minus p is 0, and then we're left with the point q, which is what we were expecting to get there. So a third point, you can just use any time that you wish, time 2, so L of 2. A couple ways to do that. You could just put in 2 wherever you saw the t, which would give you 5 comma 6. Okay. Or you could have used the vector form. L of 2 is the point p plus direction vector times 2, but our point was 1, 2, our direction vector was 2, 2 times t, and t is 2 in this case, so that would be 1 comma 2 plus 4 comma 4. Adding those 2 points together gives 5 comma 6, and you end up at the same place. Okay, so this is our line. Our line happens to be in 2 dimensions. Okay, so all we needed was a point and a direction vector times t. Okay, the same result holds in any dimensions really. So let's do another example, maybe in 3 dimensions. Okay. So let's construct a line L of t in 3-dimensional space. And let's say that this line L of t, it goes between the points p is equal to 1, 0, negative 2, and q is equal to 3, comma 1, 0. Okay. So what we have here, just a general sketch, is we have 2 points in 3-dimensional space. First, I would like to find the direction vector of this line. Okay, we'll call this v, which we know is going to be the vector from p to q. And then we would like to find a line that goes through one of these points, say p, it also goes through q, and we'd like to find the equation of this line. Now it's going to be of the form p plus direction vector times t, where our point p is 1, 0, negative 2, and our vector, direction vector v, is going to be the vector from p to q. Okay. So finding the vector from p to q is simply doing the difference of 2 points. q minus p is going to be 2, 1 minus 0 is 1, 0 minus a negative 2 is 2. So there's our direction vector. Therefore, our line is of the form 1, 0, negative 2 plus 2, 1, 2 times t. Okay. And therefore, at t is equal to 0, our line is at the point p plus v times 0, which is at the point p. So we're at this point at t is equal to 0. At t is equal to 1, we'll be at the point p plus v times 1. But our vector v was p to q. P to q vector is the difference of 2 points, and therefore the p's cancel and you're left with q. So we are at q at time t is equal to 1. So we're moving along the line in this direction. Okay. You could pick any other time. We'll be somewhere along here, these points, maybe at times between 0 and 1. Okay. So there are two examples of the equations of lines. And that ends this video.